So in this loop, let us assume the current is I1. In this loop, let us assume the current is I2. And in this loop, let us assume the current is I3. So now we are going to apply KVL in these different loops. So apply KVL in loop A, B, G, H. So what will be the equation? We are taking the direction of I1. We are taking direction like this. This. We are taking the direction of I1. So here you can see the current in 10 volt. The direction of current in 10 volt is from negative to positive. Therefore, here gain is occurring. Therefore, we represent 10 volt as plus 10, and the potential drop across 5 ohm is represented by, since it is potential drop, therefore we represent it by minus sign 5, and the current across 5 ohm is I1. Therefore, 5 into I1. Potential drop we can calculate it by using the formula V is equals to IR. So V is I here in 5 ohm resistor is I1 and resistor is 5. Therefore 5 into I1. And the potential drop across 25 ohm is represented by minus 25, and the current in 25 ohm is I1 minus I2. Since we are taking the direction of I1, we are taking the loop 1, that is A, B, G, H. Therefore we are taking the direction of I1. Therefore if we are taking the loop A, B, G, H, then the current across 25 ohm is I1 minus I2. But if we are taking the direction of I2, that is, if we are taking the loop B, C, F, G, then we have to take the direction of I2, and then the current across 25 ohm is I2 minus I. But in this case, since we are taking the loop 1, that is A, B, G, H, therefore the current across 25 ohm is I1 minus I2. We should consider the direction of I1. And the direction of current in 20 volt is from positive to negative. Since we are taking the direction of I2, therefore the direction is like this. Therefore loss is occurring. Therefore we represent 20 volt as 20 minus 20 is equals to 0. Solve this equation, we will get 10 minus 5i1 minus 25i1 minus minus plus 25i2 minus 20 equal to 0. Now the equation comes out to be, take these terms, these three terms to the right hand side. Therefore we will get minus 20i1 minus 25i2. These get plus, therefore we will get 30i1. Take the rubber. We are taking these three terms to the right hand side. Therefore we will get, these both terms will get added. Therefore this will come out to be 30i1, and we will take this to the right hand side. Therefore it will get positive 30i1 minus 25i2 is equals to, these both get minus, therefore minus 10. Equation first. This will be equation first. Now we will apply KVL in loop B, C, G, F. Therefore, we will get equation like, here we will consider the direction of I2. Therefore, the direction of current across 20 ohm will be from negative to positive. Gain is occurring. Therefore, it is represented by plus 20, and potential drop across minus 25 ohm is minus 25 into I2 minus I1. Since we are taking the direction of I2, therefore the current that will be considered across 25 ohm will be I2 minus I1, and the potential drop across 15 ohm will be minus 15 into I2. Since the current across 15 ohm is I2, potential drop across 20 ohm will be minus 20. Since we are taking the direction of I2, therefore the current across 20 ohm will be considered as I2 minus I3. Whatever loop we are taking, we will consider the direction of that loop current. Okay, if we are taking the loop third, that is C, D, E, F, we should take the direction of I3. Then the current across 20 ohm will be I3 minus I2. But in our case, we are taking second loop, that is B, C, F, G. Therefore, the current across 20 ohm will be considered as I2 minus I3. Therefore, the potential drop across 20 ohm will be represented by minus 20 into I2 minus I3. And the current direction in 30 volt is from positive to negative. Therefore loss is occurring. Therefore it is represented by minus 30 is equals to 0. Now open this, 20 minus 25 I2 minus minus plus 25 I1 minus 15 I2 minus 20 I2 minus minus plus 20 I3 minus 30 equal to 0. Now solve this. 20 minus 30 is minus 10. 25i2, 15i2, and 20i2 will come out to be minus 60i2, and 25i1 plus 25i1, and 20i2, I3 is 20i3 equal to 0. So what will be the equation? take these three terms to the right hand side. So we will get the equation like, that is 25i1 minus 60i2. 25 will be, yeah, you can also take minus 10 to the right hand side, then the equation will be 25i1 minus 60i2 plus 20i3 equal to 10. So, so what will be the second equation? Second equation is, by taking minus 10 to the right hand side, we will get second equation like 25i1 minus 60i2 plus 20i3 is equals to 10. This is equation second. Now we have to apply the KVL in loop third. So first we have to paste this to the right hand side to the next page. This is the diagram. Let's paste this properly, paste it properly. So what is the third loop? Third loop is E, F, E, you can see C, D, E, F. So here you can name it C, D, E, F. And what's the value of this resistor is 30 ohm. So apply KVL. Now we have to apply KVL in loop C, D, E, F. So what will be the equation? Here you can see the current that we have considered in this loop is I3. So we will take the direction of I3. So I3 direction will be like this. So in across 30 volt, the direction of current is from negative to positive. Gain is occurring. So, so what will be the equation that will come out to be is, since gain is occurring across 30 volt, therefore we will represent it as plus 30, and potential drop across 20 ohm is minus 20, and the current across 20 ohm is I3 minus I2. Since we are considering the loop C, D, E, F, so we will consider the direction of I3. And this resistor is 10 ohm. So potential drop across 10 ohm will be minus 10 into I3. Since the current flowing across 10 ohm is minus 10 and 30 ohm is minus 30 into I3 is equals to 0. Now you have to solve this equation. 30 minus 20 I3 minus minus plus 20 I2 minus 10 I3 minus 30 I3 is equals to 0. Equal to, these can be added, 20 plus 10, 30, 30 plus. So this will come out to be 30 minus 60 I3 plus 20 I2 equal to 0. Now third equation will come out to be, take this to the right hand side. Therefore we will get third equation like this. That is 30 is equals to minus 20 I2 plus 60 I3. This is equation third. And now we have got three equations by considering, by applying KVL in three loops. So these three equations are, I am rewriting these three equations. First equation is minus 30 I1 plus, sorry, minus 30 I1 plus 25 I2 equal to 10. This is equation first. Second equation will be 25 I1 minus 60 I2 plus 20 I3 is equals to 10. This is the second equation. And third equation will be minus 20 I2 plus 60 I3 is equals to 30. This is third equation. Now solve these three equations either by applying Cramer's rule or by using scientific calculator. You can solve these three variable equations, and by solving these three variable equations, I1, I2 and I3 comes out to be, I1 comes out to be minus 0.54, I2 will be minus 0.25 and I3 will be 0.414. So minus indicate the direction of current. So this represents only the direction of current. I1 will be 0.54, I2 will be 0.25 and I3 will be 0.414. So we have calculated the three mesh currents here. After calculating three mesh current, you can solve any kind of question. If the question that have been asked as calculate the potential drop, yeah, calculate the drop across 5 ohm resistor. So what formula we are going to apply? Drop can be calculated as V is equals to IR. If they are asking the potential drop across 5 ohm resistor, so I comes out to be, you have seen here, I1 is 0.54. Current across 5 ohm is 0.54 and resistor is 5 ohm. So you can calculate it by 0.54 into 5. Solve this, you will get the potential drop across 5 ohm resistor. Now, if they have asked the potential drop across 25 ohm, so 20 across 25 ohm, you can see the current is I1 minus I2. Either you have to, you can calculate the current across 25 ohm by subtracting I1 and I2. So here how can you calculate the potential drop? 25 into I1 minus I2. So here you can see I1 comes out to be 0.54 and I2 is 0.25. So 0.54 minus 0.25. So here what will be 0.54 minus 0.25. So this is the potential drop across 25 ohm. If you have to calculate the potential drop across 15 ohm, so 15 ohm ke across potential drop is 15 into the current is I2 and I2 is given as 0.25. So 15 into 0.25. If you have to calculate the potential drop across 10 ohm, so 10 into the current across 10 ohm is I3 and I3 is 0.414. So 10 into 0.414 and the potential drop across 30 ohm is 30 into 0.414. So by applying these formula, you can calculate the potential drop across different resistor here. Across 20 ohm, potential drop will be 20. The difference between I3 minus I2. I3 is 0.414 minus 0.25. So it will come out to be 0.414 minus 0.25. Calculate this and you will get the potential drop across 20. So by applying this, you can calculate the potential drop across various resistors here. So this is the question 1 that we have solved.